Okay, recalling two slides Wilfried showed before, I want to put your focus on the object orientation. You remember we have a process engineering, a tag ID is being created, so this will be written into the database. In the database, all other applications, documents refer to the same objects, and thus they have the same information immediately. With that picture in mind, we go to the engineering workflow, where we start with the concept design through basic engineering to detail engineering. And this is our concept I want to show you now inside COMOS. In COMOS we have the block diagram, for example, which is the first draft of the functionality of the plant, where we have the reaction as an object. For example, we can navigate to that object into the tree, and we will see some sub-components inside, like simulation for a design case, for example. In this simulation we can import data from various systems, like for example Unisim or Pro2 or HiSys. These systems provide PFD drawings as well, so these even could be imported into COMOS and then used for further engineering workflow. In our specific case, we use the Aspen simulation. This Aspen simulation is an XML file based import, so that provides us a lot of components like equipment or streams. The streams themselves, they have general stream data. These data come from the simulation tool and are now used in the further proceeding of the engineering workflow. So with this reaction, we now can navigate to the documents below, which is such a PFD drawing I mentioned before. In our case, due to the XML file-based import, we created that PFD with COMOS means using templates. The document has a list of process streams on top of the drawing. This list is generated automatically when opening the document and is updated also automatically. So no manual input is required in that list, which reduces the effort of these drawings dramatically. When we concentrate on the reactor on the left side of this drawing, we now can navigate to the appropriate PID object, which again allows to navigate to a document like a PID drawing. We now left the feed front-end engineering and design phase of our engineering workflow and start with the PID, which is part of basic engineering. When we look at this item, we can again touch other documents, so that would mean a data sheet of the vessel, for example. And when we look into the material here on the upper left corner, then we see carbon steel. We also can open the properties of this component, which allow us to modify the drawing according to our needs. So when we look into the symbol and when we would like to have the material assigned to that symbol, we simply drag and drop it into the drawing as well. So no extra symbol modeling required, no symbols with different variants. You simply can add it into the individual instances where required, or define it in the base data for general purpose. What we see now is a combo box, for example. We see the combo box with the different materials allowed. So when we modify it in the properties mask to tantal, we will see it immediately in the drawing, but also in the datasheet with an update. Here we have the tantal. We can use the datasheet as well for editing purpose. For example, we go now to the carbon steel and close that. Then we will see that here immediately as carbon steel again. These are the possibilities to do that in an object, and the documents affected will show the changes immediately. We have an internal tracking mechanism that shows you all documents which are affected by a change need to have a new revision as well. So all documents will be listed automatically which need a new revision. With this vessel, when we proceed to the next phase, that is then, for example, the detail engineering, we can focus on the motor and navigate to documents affected. That is then for the motor, for example, the single line drawing. The single line drawing usually is used for load calculation, to see how the strength of a fuse or of a transformer or power supply and so on. From this document, again, we can navigate to the next step, which is usually the circuit diagram, which shows the motor in detail. That means which fuse is behind it, which switch do we have, and the motor appears like this. Let me arrange the drawings from left to right according to our engineering workflow. That is on the very left side our P&ID drawing. In the middle we have the single line drawing, for example, and in the right we have the detail drawing of the motor. The object orientation is again a possibility to have this motor appear in a drawing like this. When we move it to the right side in a single line, it appears like this. When we move further to the detail, it's like this. So it's one and the same object. That means when you modify the vessel, for example, to B99, the other drawings will be updated immediately. That shows you B99 in all the three drawings, and also, for example, in the datasheet if that information is available. We can go back when we select it here. We can go back when we select it once more to B001, and all the related drawings will be affected immediately. So with this kind of document, we now proceed with the automation hardware, which brings us now to the, again from the PID drawing to the pressure function. We have the pressure function here, where we can navigate once more to documents below, which gives us the automation hardware. We have this pressure sensor, we have the I/O channel, and when we open the properties of this pressure sensor, we will see a lot of technical data required. Some of that technical data is filled in automatically. That is the NEOB, that is oil filling. We have the 160 millibar to 16 bar information. This would be a request for a selection of a new device. When we now want to select the real device from a manufacturer, we recommend to use the PIA selector, which lists all our Siemens field instruments. It's process instrument analytics. And we have here the PIA selection as an option. Other manufacturers can be imported as well into the COMOS system. I want to focus on the PIA selection definitely. So that means COMOS sends now the requirements to the PIA portal, and then and there you will get an answer of all devices matching to these requirements. When we look into the C-Trans P300, it shows us a yellow diamond, which means you can configure it furthermore. So also here the information, please configure, and the requested properties you can read here are the model, the filling liquid, and so on, the minimum and maximum, and even the NEMA rating. When we selected this P300, we can now proceed with more detailed configuration that gives us the opportunity to have this item. I just browse through them with the first option selected, and the PIA selector goes deeper into the configuration and finally gives us back an order number. We can here see here at the bottom the product number. As soon as we completed the whole sequence, we will get a green button at the bottom of the line, meaning write back to COMOS. And this is the automated editing. We now see all the values are entered automatically, and we could apply them. In this case, for the subsequent presentations, I exit with cancel. So this would be the PR selector, the hardware definition of the field instruments. When we now navigate to the I/O implementation, we are now in the area of cabinet engineering, which gives us the bundle, for example, but I want to focus on this I/O. Navigate once more to the appropriate documents, which gives us the cabinet layout. The cabinet layout shows us a drawing, which is an online drawing again. If we resize the components, if we add new components, we can see here is the available space sufficient, or do we have to select other arrangements or even other depth of the cabinet. So the whole drawing appears like this. This is about the automation hardware. We also can proceed without changing. We can now proceed to the pressure function once more. We navigate to the object, and when we look into the pressure, we see the function diagram. In parallel, when we look at the position diagram here, this is our German or European appearance. We also have the documents available for ANSI standards, and this shows us exactly the same stuff. If we replace that item from a 2-wire to a 3-wire, the symbol would be affected in both of these drawings here. Let's proceed with the function diagram. This is the preparation for the automation software business, where we have some signals. The signals appear like this. The actual pressure comes into a CFC-like appearance, and when we have an interlinking or an off-page connector, we can navigate and follow this connection directly to the next page, where we again have the appearance of a CFC drawing. In COMOS 10.1 we will also support the SFCs, but I think that's it for now. With this information we can set up the library in the automation tree. I've done that already in advance because it would blow our 20 minutes session. In this area you can see the hardware configuration of the racks. You can see the Profibus with its individual bundles. This would be sent to PCS7. In PCS7, if you edit the parameters, you can re-import into COMOS, which gives you then information directly in the flow diagram, in the functional diagram, where you can see the parameters will be affected by the further engineering inside PCS7. So finally, when we did all these drawings and engineering, we want to see what it is all about 3D engineering. I have prepared a pump section where we can say, show me the pump in 3D area. Therefore, I have opened Walk Inside already with a plant view. And when we go back to COMOS and try to navigate to that pump in the 3D viewing, we will see that Walk Inside automatically snaps to that area, showing us online information. It's not a real online, it is updated by nightly builds, but nevertheless showing us the information, the technical data of the equipment, as well as the availability of a work permit, where we can then navigate, for example, to appropriate documents available from COMOS, provided from COMOS. When we go up a little bit and we have this valve, we want to select this one and to see it, what's it in COMOS. We select it and swap back to COMOS. It's this valve now. Or when we go to that motor and we want to see it inside the 3D engineering, we see it's this component. This is the full scope over COMOS. We could easily proceed with MRO, but I wanted to give you an impression about the full scope engineering workflow, and with the main message saying COMOS is a object-oriented application. Thanks for watching. Bye.